Do you ever stop and think about how tenuous life on this planet really is? We are inseparably tied to a space rock that is careening through space. We're heated in the glow of a continuous and incredibly powerful nuclear reaction, and we're kept breathing by this tiny thin layer of atmosphere that on a cosmic scale is hardly thicker than a piece of paper. Every day, billions of people live, work, and play, surrounded by trillions upon trillions of other terrestrial life forms in a nice hospitable habitat that's little more than a glorified terrarium. And that terrarium has precious few mechanisms to stop an outside threat from turning absolutely everything on its head. Look, life is incredibly resilient until the Earth's oceans boils or the planet breaks apart in some sort of horrible disaster. And in today's episode of Astrographics, we're going to dig into the disasters, the cataclysms, and the other celestial dangers that could send planet Earth back to the prehistoric age. In June of 2004, a research team at the Kitt Peak National Observatory discovered a potential planet killer, an asteroid measuring roughly 370 meters across that was destined to pass by Earth at a distance of just 14 million kilometers in December. Now that might sound like quite a large distance, but on a cosmic scale, that is basically close enough to reach out and touch it. But it wasn't that asteroid's 2004 pass that had scientists worried. It was what might happen in 2029. Given the name Apophis, in tribute to the mortal enemy of the Egyptian sun god Ra, the asteroid, like its namesake, had the potential for great destruction on planet Earth. According to studies at the time, Apophis had a 2.7% chance, that's roughly 1 in 37, of impacting the Earth's surface when it passed by at a distance of just 38,000 kilometers from the planet's surface. That's closer than some of our weather satellites, and close enough that this little rock, less than a third of a kilometer wide, will be visible on some parts of Earth with the naked eye. Now look, luckily for all of us, better measurements and better studies have now refined those numbers down to nothing. Apophis, as best we can tell, poses basically no threat to humanity, with an estimated threat level about 1,000 times lower than the likelihood that Earth would just spontaneously wink out of existence. So that's nice, but Apophis is just one asteroid in a solar system that boasts well over 1 million of them, and if just one of those little space rocks poses the sort of threat that we briefly worried Apophis did, then all of humanity is going to have a problem on its hands. If an asteroid were on course to hit the Earth, the first question at hand would be a pretty simple one. Well, how big is it? To get a sense of what an asteroid impact would mean, we've got to answer that question first. So to start, let's take an example of a pretty small one, roughly the size of a house. And for posterity's sake, let's just say that all the example impacts we discuss would hit at a speed of 30,000 miles an hour. A house-sized asteroid, under those conditions, would have roughly the same effect as the atomic bomb that was dropped on Hiroshima. Devastation within a city, including complete destruction within about a kilometer of the blast radius, and massive loss of life in the impacted area. Luckily, unlike the atomic bomb, the asteroid in question probably isn't going to bring any nuclear fallout, but we're still talking about a pretty tiny rock here on the grand scheme of things, and as soon as we start going bigger, things get worse really quickly. Let's take an asteroid about 200 feet long, which is roughly the size of a 20-story building. In this case, we're going to be looking at a blast of roughly 25 to 50 megatons, about the same sheer explosive power as the world's most powerful nuclear bombs. Detonated in downtown Manhattan, that'll leave a crater a quarter-mile wide, killing about 500,000 people within range of the shockwave, plus another 2 million from the wind blast, and collapsing reinforced buildings within about a 10-mile radius. Obviously, that kind of death and destruction would be catastrophic in that part of the world or in any population center that an asteroid could impact. But let's scale it up a little bit, shall we, and start getting toward the sort of asteroids that could really put life on Earth through hell. Let's say that this time we take an asteroid 1 mile wide and drop it on that same spot, downtown Manhattan. This time, not only do all of Manhattan and most of Brooklyn become an impact crater, but some 2 million people would be vaporized in the 10-mile-wide crater alone. The energy released would eclipse that of the last eruption of the Yellowstone supervolcano, and the shockwave would kill another 13 million people, with any person within 75 miles of the impact receiving lung damage. For 228 miles in every direction, homes would collapse, and the resulting wind blast reaching a peak speed of 15,000 1,000 miles per hour would kill nearly another 10 million people, putting the death toll close to 1/10 of the United States' overall population. The magnitude of the impact would be similar to that of a roughly 1 million megaton bomb, throwing up enough ash and debris into the air that it would have global effects. Now, let's scale that up one more time to the size of the asteroid that killed the dinosaurs, and it's at this point that we start talking about the sort of effects that would devastate life on Earth. Take an asteroid, say 10 kilometers, 6 miles across, and its effects would go beyond the hundreds of millions who would likely die from a blast if it hit one of Earth's continents, or the incredible tsunamis that would result if it struck in the middle of the ocean. The real result to be concerned about is a dust plume big enough to wrap around the entire planet, blocking out the sun for a period of years or even decades. During this time, the planet would weather incredible hardship, and while many forms of life and possibly even small pockets of the human population might be able to survive, it would be the kind of event that would destroy civilization as we know it. Luckily for all of us humans, NASA and other global space agencies are pretty good at identifying asteroids, and NASA in particular claims to have a read on 90% of the near-Earth asteroids that pose the biggest risk, ones that have a diameter of at least half a mile or 0.8 kilometers. As their estimates go, none of those asteroids have a meaningful chance of impacting the Earth within the next 1,000 years or so. Now, of course, that doesn't account for the asteroids we don't know about, but it's still pretty good news, all things considered. As new satellites and telescopes go into orbit with the hopes of cataloguing even more of these asteroids, the hope is that humanity will make a full inventory of its asteroid threats really rather soon. There's also a second piece of good news too, which is that of all the disasters on today's list, an incoming asteroid is one we might not have to worry about for long. In September of 2022, a NASA spacecraft known as DART tried something new, crashing into an asteroid, in this case a stadium-sized rock called Dimorphos, in order to alter its course. The mission was, shall we say, a smashing success, and indicated that at least in principle we've got an effective way to protect Earth if another asteroid comes calling. Of course, there's the issue of what humanity would do if a threatening asteroid was a lot bigger than Dimorphos. It's very difficult and expensive to launch anything into space, let alone a giant sledgehammer that could knock a miles-wide asteroid off course. But if the choice comes down to either paying out or having civilization destroyed, then the answer may come down to just sucking it up and dropping a few $1 billion on a space javelin. Alright. Before we move off the subject of celestial impacts, let's talk about another potentially unwelcome guest, a comet. Most scientists believe that a comet impact would have a significantly more serious impact on Earth than an asteroid would, at least in a pound-for-pound sense, and that's for two key reasons. First, comets are much more likely than asteroids to impact Earth head-on, rather than simply getting ensnared in Earth's gravitational pull and spiraling down towards the surface at an odd angle. And second, they travel a hell of a lot faster, up to 3 times as fast as an asteroid would at the moment of impact. That means a bigger explosion, a bigger crater, and a hell of a lot more damage. And it also means that because of how fast comets move, they could be hard to spot if they're traveling headlong toward Earth until a particularly dangerous one is right on top of us. Best case scenario, Earth might get about 2 years warning, and while that's certainly not nothing, it's not quite enough to give any peace of mind. The trajectories of comets are also highly variable, particularly as they heat up and get closer to the sun, meaning that a comet that's thought to be dangerous could miss us entirely, or one that seems innocuous could very quickly change course. The good news about comets is that although there are likely billions of them out there, they don't tend to come close to Earth. Instead, they inhabit the solar system's extreme outer edge in the Oort cloud, and very rarely venture into near-Earth territories that are largely the domain of asteroids. Although it's hard to place a likelihood on the event for sure, a comet impact is thought to be about 100 times less likely than an asteroid impact of comparable size. Comet impacts are estimated to take place only about once every 45 million years. The bad news is that comets wouldn't just hit Earth at a higher velocity or at a more devastating angle. They can also be quite a bit bigger, with the Hale-Bopp comet, for example, boasting a course somewhere between 27 and 42 kilometers, or 17 to 26 miles in diameter. Add all those factors together and comets quickly become the celestial body that poses the highest risk of truly devastating impacts with Earth. It's not particularly likely, and on a cosmic scale, not particularly massive, but at an intersection of impact, likelihood, and mass, that gives comets the highest bang for their buck. Add to that the off chance that a celestial body of some kind could pass through the Oort cloud, sending a shower of comets scattering in Earth's direction, and there's a non-zero chance that one of those massive comets will smash into Earth at some point. Luckily, the chance that sort of impact would happen in our lifetimes is, well, good news, it's infinitesimally small. Alright. Let's move over now to a civilization-wide event that doesn't necessarily have to destroy humanity, but certainly could. Extraterrestrial arrival. We've touched on this concept already on Astrographics with a video on how first contact with an alien civilization might work, so do check that out if you're interested to learn more. But to put it simply, any alien species that can arrive on Earth or use technology to exert influence here is necessarily going to be a lot more advanced than we are. Barring a War of the Worlds style incident where an alien race is simply wiped out by unexpected pathogens, the circumstances of a first contact will probably not be in humanity's control, meaning that the intent of these new arrivals is most likely going to dictate what happens. First contact isn't unheard of between humans. For example, the Columbian exchange between the Old World and the New World beginning in the late 1400s was a massive first contact event with global implications. At least in human history, first contact usually leads to the destruction of the civilization that has foreigners show up for the first time on its shores. Sometimes that destruction comes via war, other times by pathogen, other times by enslavement and forced relocation. And all of these very human hallmarks of first contact could very well apply to an extraterrestrial arrival too. Of course, we can only speculate on what exactly a first contact situation might turn into, but the myriad worst-case scenarios could include deliberate extermination of the human race, perhaps to get at our planet's resources, perhaps to eliminate humanity as a threat, or perhaps because an extraterrestrial species either doesn't recognize us as life forms or just doesn't care about preservation of life forms at all. Enslavement of the human race is also on the table, as is a forced culling of the human population, perhaps not meant to drive us into extinction, but to control our population in the same way that we do with rats or wild boar. And although to us humans on Earth, the thought of doing this sort of thing to another population of our own size and technological advancement would be a Herculean task, it might be quite easy for a civilization that can travel the stars and then show up on our doorstep. Do not let Hollywood fool you. If the aliens show up with hostile intent, it's highly unlikely that any human counterattack is going to be successful. Sure, we've got nuclear bombs. Sure, that might help, but those weapons would likely be absolutely eclipsed by whatever our extraterrestrial friends or not friends are packing. Even if humanity got its own version of Russell Cass from Independence Day, willing to crash into a flying saucer's primary weapon in a heroic act of self-sacrifice, it's probably not going to do very much. Then factoring the strong possibility that a civilization smart enough to reach Earth is probably also smart enough to do a bit of reconnaissance before they show up and present us their space demolition paperwork, and suffice to say, it's not looking good for humanity. As for how likely this is, it is impossible to say. Humanity has no data point to reference on the likelihood of alien civilizations or of alien visits or how frequently aliens might be hostile. It's completely and totally speculative, and we've no way to anticipate a hostile act from another civilization until it shows up on our doorstep and does things that are actively hostile. But according to some scientists, including the late great Stephen Hawking, it's entirely possible that humanity's new ability to broadcast radio and TV signals might put us on a hostile civilization's radar where we might not have existed before. And if aliens are watching our TV, that means they're acquainted with Cocomelon, which is absolutely justification enough to destroy all of humanity. Next, let's bring back the idea of collisions, but venture off into some more speculative territory. The potential for other celestial bodies, not just comets or asteroids, to pose an imminent risk to our planet. We'll break this into two major types of threat: a rogue planet and a black hole. A rogue planet is any planet that is not attached to a star. While in some cases these planets move relatively slowly or barely at all, others are believed to travel through the galaxy at high speeds. If one were to come close enough to be captured by the gravity of our sun, or if it happened to be transiting in a way that caused it to shoot through the solar system, it's entirely possible that this might have an effect on planet Earth. There are three main ways that this could happen. First, we can simply think of a planet as an object with a lot of gravity, meaning that when it travels through the Oort cloud, as we mentioned before, it might disrupt any number of comets, asteroids, and other space debris, making it much more likely that one could come in at the wrong angle and cause problems on Earth. We can feel at ease about a threat from comets when, say, 10 a year pass close enough to our sun to be noticeable at all, but things get a lot hairier if, say, 50,000 comets suddenly came careening through the solar system for no discernible reason. In the second scenario, a rogue planet might transit closely enough to Earth to disrupt our own planet's orbit, either by a little or by a lot, or disrupt the orbit of another solar system planet enough that it causes problems for Earth later on. That could mean throwing Earth toward the sun, or putting it in a further out orbit, starting a freeze, or even catapulting Earth out of the solar system and making it a rogue planet of its own. And the third scenario is the obvious one. an entire planet coming out of nowhere and impacting Earth. This is the sort of cataclysm that would most likely scrub out even the last traces of life. In the event that Earth is hit by a gas giant-sized planet, say about the size of Jupiter, then it might simply swallow the Earth into it, either with a head-on collision or by entrapping it into a deteriorating orbit that eventually sucks it in. If Earth is hit by a planet its own size, or more conservatively the size of our own moon, it would fracture the Earth's crust with enough force that it would splinter all across the planet, opening innumerable fissures from which the Earth's mantle is exposed to the atmosphere. That atmosphere, by the way, would quickly be ripped away as incredible shockwaves and heat encircle the planet, making this apocalypse into a race to find out whether the last human is killed because they got barbecued, vaporized, or just suddenly exposed to the vacuum of space. Either way, it would be an incredibly nasty experience, one that no known form of life could possibly survive. So now let's talk about what a black hole would do. And for that, we've got to talk about what kind of black hole we mean. A microscopic black hole probably won't have much effect, while the black hole of the size that would result from a supernova absolutely would. Just like the rogue planet option, a passing black hole could send comets and space debris toward Earth, or push the Earth out of its current orbital pattern around the Sun. But if it were to be on a collision course with us, the problem wouldn't be that the Earth is going to smash into it, or at least by the time that happens, well, we'll all be extremely dead. The thing we would experience, or at least if we live long enough to see the Earth coming, is for the Earth to begin to come apart, with whatever part of the planet is closest to the black hole starting to rip apart. Since the black hole's influence is one of pure gravity, it would impact everything on Earth, first stripping away the atmosphere and killing anything air-breathing on the surface, then breaking through the Earth's crust and eventually turning the entire thing into a molten ball with parts of the mantle and then the core distorting space and time and stretching matter into long spaghetti-like tendrils that are eventually consumed. In either case, these are threats that we might not see coming until they're about to have an impact. A black hole traveling through interstellar space with no real amount of matter to feed upon likely wouldn't give us any indication of its presence until it comes close enough to distort space and time from our perspective, and rogue planets, especially if they are relatively non-reflective, would be discovered at about the same time, since there's no nearby star for them to cause an observable wobble like other exoplanets do. And if we did see either threat coming, the best case answer for Earth would be to simply try and dodge, which, yes, means that humans would have to invent a way to move our entire planet. We can at least take comfort in the fact that according to models done with the known data, the risk of such an event is incredibly low. There are probably about 1 billion black holes and several billion rogue planets at minimum wandering around the Milky Way as we speak, but the Milky Way is really, really big. We're talking about 1 billion, 1 in a trillion, 1 in a quadrillion odds that a rogue planet would transit close to Earth in the next millennium. The odds of a black hole doing the same are even smaller. However, we've got to take even that news with a grain of salt, considering just how incomplete our knowledge of rogue planets and wandering black holes is. These odds could either be a lot better or a lot worse compared to what we're currently able to calculate. Put simply, don't stay up at night worrying about this one. If the science changes enough that we should be concerned, then we trust that global news is going to be pretty eager to let us know. And last of all today, we've got the cosmic cataclysm that in some ways is scariest of all. A gamma ray burst. These massive beams of radiation happen when large stars run out of fuel and collapse. A natural step at the end of their lifespan, but one with a pretty serious knock-on effect. The collapse of a star causes, among other things, the formation of very strong magnetic fields at the star's poles. And because of some physics that we're going to just gloss over today, the dying star ejects a jet of plasma out of its poles at very nearly the speed of light. Along with that plasma comes electrons, positrons, and the thing that we are particularly worried about, gamma rays. The energy beams are so powerful that they produce about as much energy as the sun does in the span of 10 billion years. Except in the case of these energy beams, the blast lasts less than a second. Once they're produced, they go shooting through space and destroy just about everything in their path, slowly losing intensity over time until they peter out a few tens of thousands of light years away from their source. We've got to emphasize here that these are not common occurrences. Gamma ray bursts are only believed to happen a few times per galaxy every million years or so. They're also hard to observe because if you're not directly in their path and they shoot into empty space, there's no real way to tell whether they happened. But now, we get to the rather chilling part. If a gamma ray burst did happen, and it was pointed at Earth, it's coming towards us at the speed of light. Nothing moves faster than the speed of light, meaning that we would have no way to tell whether a gamma ray burst is coming until it is here. The supernova that causes it will only become visible in the instant that the gamma rays arrive, and any other indicator, including that beam of plasma, would take a very long time to arrive after the gamma rays' damage has already been done. And this isn't the sort of space disaster where a few scrappy survivors get the chance to carry on humanity's work after the rest of us are gone. It's not even the sort of space disaster where we get a pretty light show in the sky before we perish. It's the sort of disaster where all of human life, and potentially all life on Earth, just winks out in an instant, too quick for our bodies to feel pain or even perceive that something's happened. One second we're here, the next second we're not. It's just that simple. What exactly happens in this process depends on how close the gamma ray burst is. Of course, it also matters that the gamma ray is pointed at us. Like any beam of energy, it's got to be very precise, and it's not going to have an effect on Earth if it's focused a little too far one way or the other. But if it does point at us directly, then the level of destruction will be contingent on proximity. If the burst happens less than, say, 200 light years away from Earth and it's aimed just right, many theorists believe that the entire planet would be just vaporized instantly. Not the exterior, the entire thing. If it happens from further away, but anywhere in the Milky Way, then it's still close enough to completely sterilize the side of the Earth that faces into the blast and rip away the atmosphere, killing everybody on the other side too. Even gamma ray bursts from over 1 billion light years away have caused radio disruption on Earth, showing just how incredibly powerful those beams are, and it's thought that the Ordovician Silurian mass extinction here on Earth about 440 million years ago that saw about 85% of global species exterminated might have been caused by a gamma ray burst as well. Now, we've got to emphasize again that this is an incredibly unlikely event for Earth to be caught up in, at least in any way that would put an end to human life. Luckily, it's also the kind of event that we can at least spot the likely culprits for before they happen, analyzing stars near Earth to try and identify as many candidates as we can. As of now, we aren't aware of any stars near Earth that could annihilate us in this way, so that's at least a good start. And even if there was, there's a strange peace of mind in knowing that there's at least one cosmic destroyer that just winks us out of existence. No pain, no suffering, and no knowledge that we're even gone. I mean, call us crazy, but if we've got to go out in any of the ways on this list, I don't want that black hole coming in and turning me to spaghetti. I'd rather a gamma ray burst every time. Thank you very much.